All right, what's up, everyone? Welcome back to the channel. Hope you guys are enjoying the videos thus far. Today, I have a special guest with me. His name is Anish, and he is currently a quantitative analyst and a quantum software developer at a company called 1QBit. He is also a grad student at Knight, working in the field of theoretical nuclear physics. So, welcome to the channel, Anish, and thanks so much for being here.
Yeah, no, thank you so much for having me. I'm always excited to talk about physics and what I do. So, always happy, always ready.
Yeah, man. I mean, physics is a really complex field. I think a lot of young science students they really struggle with physics, and I think it's definitely one of the hardest courses among the general sciences. Can you tell me a little bit about what got you into physics in the first place and how you just overcame that hurdle of being able to learn the basics and then get into the advanced physics as well?
Yeah, sure, that sounds good to me. So, physics to me was always the most interesting thing in the sense that it allows us as people to understand the very fundamentals and the very basics of the universe, both on the tiniest possible scale as well as to the largest, right? The size of the universe and even beyond. Um, so really I've always been passionate about understanding how everything works. I feel like every kid has that in them to some extent, right? They look outside, they wonder why the sky is blue, right? They're playing with their computer, they're like, I wonder how this works. And physics encompasses all of that and so much more. So that's why I was interested in physics. Now, as for getting into it and really getting through that hurdle, I found that really my desire to understand this and my passion for that really motivated me to be okay with with the punishment that comes with studying physics. It is tough indeed, and I completely understand. I went through a physics undergrad degree and I'm doing my graduate degrees now, and it's tough, but it's so fundamental, or it's so remarkably rewarding for me, right? You spend hours working on a problem and then you're like, yeah, I finally did it. And sometimes it has some practical uses.
Yeah, for sure. So about those practical uses, so now you're working as a quantitative analyst and as a quantum software developer. Can you tell me a little
Mhm.
bit about what that field of work is like and what you're sort of doing and how you're applying physics in the industry now?
Yeah, sure. No, I'd be more than happy to. So I'll speak more on the quantum software development side, right? So I work at 1QBit, which is a quantum software development company, right? So quantum is gonna pop up a lot in this conversation. So I'll get more into that in a little bit. But effectively, what 1QBit does, is they're designing software, right? So that they're programming um, to make use of up and coming quantum computers to hopefully solve some of the hardest computational problems around the world right now, right? Some examples of this are dealing with um, drug design and development, right? So again, these are general problems. Whenever it comes to the simulation of molecules, it's a very difficult and computationally heavy problem. But with the power of quantum computers and the speed ups that they bring, the idea is to use quantum computers in order to simulate these inherently quantum systems. But again, it's not strictly limited to physics, right? To physical and chemical problems. It can also be applied to things like finance, which is what I'm doing on the quantitative analyst side, right? So what what my team is doing is we're developing a product to help analyze and assess risk when it comes to the financial markets. And effectively, what this does, or what one needs to understand, is that the futures market, the financial markets in general, they are they are stochastic, and there are very many inputs, right? So it's a practically impossible system to fully analytically model and understand. So we have to use our best thinking, our best math, and the computational tools at our hand in order to try to try to tackle this like astoundingly complex problem. And with quantum computers, using their speedups, we can produce these amazing results. And that's how we are applying quantum physics in general, quantum computing, to real world problems.
Nice. And can you sort of just break down exactly what you mean when you say quantum physics overall? Like, what would that be in just layman's terms for just the general audience?
Sure, I think that's a valid question because I've said quantum who knows how many times now, right? So quantum physics, I think at the simplest level, is the study of the very, very small. So really what it is it is a series of frameworks, right? Mathematical, physical frameworks that are designed, that are that were developed to explain the most fundamental of forces, right? So we have the electromagnetic force, right, which governs currents and magnetism, stuff like that. We have we have the weak force, which covers certain nuclear decays. We have the strong force, which governs everything that happens within the nucleus itself, right? So it's why protons stick together. It's why nuclei can take the shape of a sphere or an ellipsoid, and so on and so forth. Now, there's also gravity, which is a little problematic. It doesn't really fit into the standard model as it is, and the standard model is the quantum physical framework that that describes the strong force, the weak force, and the electromagnetic force in through the language of math and quantum physics. Gravity is a little tricky, specifically because from Einstein's theories, it relies on a continuous sort of universe, not a quantized universe. And what quantized means is that you have things that occur in quantized packets, right? So you have 1, 2, 3, as opposed to like a spectrum, right? So instead of 1, 1.1, 1.11, and so on and so forth. So quantum physics is a study of the very small and the most fundamental of the physical forces.
Okay, that breaks it down. That helps us out a lot for all of us people who really never got past first year physics and didn't go as far in depth as you did. Can you tell us a little bit about how you can actually use physics within the industry and throughout the field? So similar to the field of work that you're doing, and sort of just aside from engineering, because I think most people, when they think of physics, they think of engineering students and how they apply physics into all the things that they're building and designing and things like that. But what are some other ways that you can apply physics in the industry aside from engineering, or even in the field of work that you're doing as well?
Yeah, sure. So again, I think quantum physics in general is an an amazing broad field of physics, because right now I would say it's most of the research that's being done, right? At least when it comes to the scale of things smaller than people, right? So like, just to touch on engineering just a little bit, because I do think that there are some really exciting problems being tackled right now, is the applications of quantum physics, right? So quantum mechanics, stuff like that, and the principles that are within it uh, are being used right now to help develop new and exciting devices, right? So new, and not just things like electronic devices, but also materials, right? So materials that can be used to help build very strong things, materials that can be used within medical devices to make materials that can carry information, right? Which is more applicable for the quantum computing side, right? Dealing with silicon, excuse me, and designing qubits. Um, it also has a lot of applications in medicine, right? So whenever, or what's being done now, because we're in the modern age, is a lot of work is being done in um, image analysis, right, and medical imaging. So I think the most popular example is MRIs, right? So we've all seen an MRI. We all know what an MRI is, but it inherently relies on a quantum mechanical thing called spin and relaxation. And spin is a fundamental property that everything has, right? Especially which is far more apparent on the quantum level. So on the scale of atoms and molecules, where basically you use a very strong magnetic field to excite the spins of particles and let them relax. And by doing some fancy image analysis, pardon me, some fancy computational techniques, then you're able to create an image and use that to, well, see within the human body, right? And you know, the ones that people have seen on shows like House and Grey's Anatomy, those were those were those were using older techniques, and those techniques have been far more sophisticated. And now we can have these amazingly detailed images that are just remarkable to me. And again, it's not limited to MRIs, right? We also have things like like PET scans, right? So
Yeah.
uh, positron emission tomography,
Yeah.
which basically means that you you stick you inject into the body some very safe particles that emit positrons, which then react in your body and annihilate, because physicists like to use scary words.
Yeah.
Um, and then the photons, the light that comes out of it, are registered by a machine, and that gives you a very good idea of like what certain parts of the human body look like. And speaking more on the side of nuclear physics, we can create radionuclides, tracers, things that we can put into the body of patients to help safely identify where cancer is, for example, and help treat it too.
Hmm.
Uh, Oh, and I think the last sort of thing that I'll talk about is applications to cryptography, right? So there's a little bit of fear when it comes to quantum computers, right? Because right now everything uh, is encrypted using classical methods, right? And what that means is that they rely on classical computers and the framework within them, right? So you have bits, you have ones and zeros, and a bunch of fancy functions to sort of make sure that all of our data is safe and all the passwords can't be hacked, right? And there's this fear, there's this maybe semi-valid fear if you don't really look into it, that by building quantum computers, you can crack these codes, right? And just completely tear down all semblance of computer security, which is bad because everything relies on it, right? But there, but there's this thing, or there will be this thing called quantum cryptography, right? And basically, right now, researchers are seeking these robust methods of manipulating quantum states, right? In order to develop new cryptography methods that rely on quantum mechanical, quantum physical properties. And and hypothetically, right, you'd be able to create these these ways of encrypting things that are impossible to crack, even with quantum computers.
Hmm. That sounds really interesting. And if you want to work in all of these fields, what's sort of like the educational pathway or the journey like to get into these fields? What are sort of the requirements that you need to do in terms of schooling and training and stuff like that?
Yeah, it's a great question. So truly, you can do honestly, you can do a lot with just a bachelor's degree, right? So if you have a bachelor's degree and you've done some research work, chances are you know someone, like a prof who knows someone in industry that can help you get your foot in the door for a job, right? And there are a lot of tech startups actually that are looking for physics majors in particular. One, because physics majors are trained to solve problems very, very well.
Hmm.
I'm a little bit biased given that that's what I studied,
Yeah.
but I think it holds absolutely true, right? Like one of a colleague of mine, he applied for a job with Mercedes Benz doing material design basically,
Hmm.
right? And so he got the job, right? And the thing that set him apart from all the other people that applied was the fact that he had a physics background, right?
Hmm.
Um, I know some other people that go directly into finance, where once again, because of these, with just a bachelor's, because of these problem-solving skills that they have, they're very much able to break into the field and learn the tools of the trade very, very easily.
Hmm.
Now, if you want to go more of the route of proper research and even medicine, you will need a graduate degree of some kind, right? Whether that be a master's, a PhD, or even an MD, right? So I would say that to get into the field of physics in general, really all you need is a bachelor's degree. Having a graduate degree helps a lot, of course. I think that's true with anything, right? Like if you show up to a job interview and you have the prefix doctor, for example,
Yeah.
right? It's going to help you out just a little bit.
For sure. Yeah, so there's definitely no doubting the fact that a physics major is really valuable in the industry in terms of what they're doing. And I think that's a little bit in contrast to a lot of the science degrees that people are getting, where most
Mhm.
people, if they get a science degree, it's either like medicine or another professional school or research. I think with
Yeah.
physics, you're able to start working in the industry as well, which is really valuable. What sort of advice would you want to give to someone who does want to do something like this, but they're struggling with physics a little bit more than they thought they would, which I think a lot of us can speak for when we first try to get over that hurdle? What advice would you give to those people?
Yeah, no, I think that's a great question. You know, I think absolutely. If you decide to study physics, or even if even if you're taking a physics because it's required for your like chem or bio or whatever degree, right? I I think people, I think one should internalize the fact that it's okay to fail. It's okay to struggle, right? That's how you learn. And really, I think that coming out of high school, for example, a lot of students really struggle with physics in particular because it's a tough course by trade, right? Just by design, and they're so used to getting like like 90s and hundreds or what have you without putting in a lot of effort, right? And the second that they face adversity with this in this aspect, then they feel defeated, and that's what I feel a lot of people that's what I feel takes a lot of people out of physics, right? They get to those first or even second year courses and they're like, you know what, I'm not doing well, and it's really defeating. It's very humbling to me, and it's quite unfortunate, right? But I think like keeping your head up high and understanding that it's not just you who's doing poorly, right? It's your peers are as well, and all you need to do is understand that all this hard work, all this hardship will make you stronger as both a career person and as a person in general.
Mhm.
uh, which is why I tend to find that people who go further into physics are fall into one of two categories. They're either hyper confident or they are very, very humble, right? They're either the nicest people you'll meet or fairly arrogant people.
For sure.
um, I like to think that I'm humble, but
No,
I'm sure.
I would agree. You're good.
Anyways, so in short, my advice is no matter how hard it seems, okay, no matter how tough it might be for a person studying physics, taking a physics course, just understand that your peers around you are having trouble, and it really is a collaborative science. Don't be afraid to ask for help. Don't be afraid to work with others, and don't be afraid to put in those extra hours.
For sure.
It will absolutely help you, to pursue physics, and I think everyone around you will be more than willing to help.
For sure. I think that's great advice. Definitely. And sort of the last question I want to ask you in terms of going forward with the future and a lot of people who want to get into the field now, I think it's good for them to understand if they do go into this field, what is the future going to be like? And I think with physics, because things are just changing constantly in terms of the discoveries that are made and how technology just keeps on advancing, it's good to know where the future is going to be. So as a general question for you, based on your experience in this field, where do you see
Mhm.
the field of quantum physics and nuclear physics? Where do you see this field going in the next 10 to 20 years or so?
Sure, I think that's a great question. So I'll speak on three fronts. So first is just general physics. Second will be um, what we're calling quantum physics, and then the last will be nuclear physics.
For sure.
So with physics in general,
Mhm.
I think there will effectively always be a need for this sort of thing until we can develop AI that can think better than we can, right?
Yeah.
But I think that's a long ways away.
Mhm.
So there will always be a need for physicists in the sense that people will always need problem solvers. People will always need those that can do both engineering work as well as the more theoretical work, right? Um, so I think that if you're able to market yourself, you can do just about anything with a physics degree, right? I mentioned earlier in the interview that that I have colleagues that went into finance. I have colleagues that went into software design. I have friends that are going into medicine, right? A whole bunch of things, and it's all because they were trained to solve problems systematically and very well. And the fact that they can pick up just about anything, I would say.
Yeah.
Um, so I think, in a general sense, where the future of physics is going is, or rather, there will always be a need for those who study physics,
Yeah.
and where the field is going in general is we do keep getting more and more advanced, and there are more and more discoveries, but that just creates more and more opportunities, right? So people were afraid of computers and calculators when they first came out, right? Because they're like, this is going to kill all the jobs, but it didn't. It created more and more, and we were able to advance as a society. Bless you. And
I'm
Bless
good.
you once again. All right. We were able to go to the moon, right? Like it's amazing to me. It's absolutely stunning. So I think that with the more discoveries that are being made, the more opportunities there will be. And I think that physics majors will always be needed and wanted.
I agree for sure. And then just one sort of last follow-up question to that. What do you think it is about doing a physics major that really makes someone valuable? Because you talk a lot about problem solving and being able to do a variety of different things with a physics major. But when we talk
Mm.
about other different college or university majors, people really don't have that same access to the same job opportunities or the same professional schools to apply to. So what do you think it really is about being a physics major that makes someone valuable, aside from just, being able to solve a lot of complex problems?
Sure, and I think this speaks a little bit to what I was saying, to the advice that I was giving for people that want to pursue physics. So I think again, it teaches a bunch of skills and all that crap, right?
Yeah.
But I think probably the most important thing that I personally gained from a physics degree, and I think a lot of my friends and colleagues would agree with this, is the ability to work under pressure and dealing with these very, very difficult problems, right?
Mhm.
So I I loved physics as a degree because it brought me closer to everyone around me that also studied physics, right? Because we were suffering together.
Mhm.
And that sort of underdog mentality really stays with you, and it makes like us as people hungry, right, for new opportunities and excited for when we solve a problem. Whereas in other disciplines, for example, biology or even chemistry, right? It's very much you have a goal, you have a wide dictionary at your disposal, right, in your head, from from memorizing things as well as the understanding of different procedures, right? But quite often, those aren't the most versatile of skills, right?
Right.
Whereas with physics, the fact that you have that grit that was just drilled into you by years of suffering, of years of fun, as well as the fact that you have a skill set that can effectively, it has taught you how to learn, right? It has taught you to be okay with failing because you know that you can succeed with a little bit more hard work. I think that's what separates physics from other degrees, and I would even say that it separates you from people that pursue math degrees, right? In the sense that you both learn math, and mathematicians will be like, oh, physicists don't know math, which is fair. um, but what you do gain is an understanding of when to use all of these mathematical tools that you learn, right?
Mhm.
Whereas with math, you learn how to prove things, and your logic is fantastic, right? It's incomparable to the other STEM fields.
Yeah.
Um, but I wouldn't, if I had a choice between hiring a math major and a physics major, where specifically a problem, I would need someone who sorry, between hiring those two people for a problem that doesn't have a solution or a clear path in mind, I would pick the physics major, specifically because I know that they can put in the work and really have that vision where there's like effectively like a blank canvas to go.
Mhm.
Whereas with another STEM major, they would need far more rigor or guidelines.
Mhm. For sure. Well,
Yeah.
that really sheds a lot of light on just how valuable the field of physics is, not just in
Mhm.
engineering, but in medicine and finance and a whole bunch of other things as well. So thanks so much, Anish, for being able to do this interview and really tell us a lot about the field of physics, especially quantum physics, which I think a lot of people find very interesting. Just
Yeah.
probably not as interesting as you, so we can actually do it in grad school and undergrad as well. But nonetheless, we really appreciate it. Do you have any last words before we sort of end off on the interview?
Sure. I suppose I wouldn't be doing my field justice if I didn't speak on why I think nuclear physics is so fun and exciting, and why I think people should pursue it.
Mhm.
So nuclear physics, to me, the nucleus in particular, has been the most interesting um, body in the quantum realm, right? It's this wonderful playground where all the fundamental forces come into play, right? And on top of that, you have the most beautiful and amazing math I think that you'll ever see, where you have these quantum effects that come into play, as well as classical effects that come into play. And there's been so much advancement in the field of physics, right? That was done by nuclear physicists in particular. So I really recommend to all the young physicists out there to take a look at nuclear physics and to see what it might hold in store for you, because you never know where it might take you, right?
Yeah, 100%. Thanks so much for that last bit of advice, Anish. That does end the interview. Hope you guys enjoyed that video, and be sure to subscribe to the channel if you haven't already done so, and I'll catch you all in the next video. All right. See you, Anish.